Electrochemical cells, the Voltaic cell. I'm Mr. B. A Voltaic cell consists of two electrodes connected by wire through a device. The circuit is closed with a salt bridge. In a Voltaic cell, chemical energy is converted to electrical energy. In other words, a Voltaic cell generates its own energy. Batteries are indeed Voltaic cells. The Voltaic cell utilizes a spontaneous oxidation reduction or single replacement reaction to generate electrical energy. A Voltaic cell consists of two half cells containing aqueous solutions. And each half cell contains a different metal electrode. The electrode called the anode consists of the most reactive metal. The electrode called the cathode will consist of the least reactive metal. To determine the anode and cathode, refer to reference table J. The most reactive metal will represent the anode. This metal will undergo oxidation. And the least reactive metal will represent the cathode. The metallic ion of this metal will undergo reduction. During oxidation, electrons are released. Oxidation occurs at the anode. Because electrons are released by the anode, is given a negative charge. During oxidation, the anode will decrease in size. The electrons produced from the oxidation of copper will travel from the anode up the wire through the voltmeter towards the cathode. Because the cathode attracts electrons, it's assigned a positive charge. During reduction, electrons are gained. Reduction occurs at the cathode. At the cathode, electrons will reduce dissolved silver ions. The silver metal produced will then plate onto the silver cathode, causing it to increase in size. The salt bridge contains an aqueous salt. The salt bridge also prevents the mixing of the solutions in the two half cells. The salt bridge allows the migration of ions between the two half cells. Initially, this particular salt bridge will contain only aqueous potassium nitrate. But when that runs out, aqueous copper 2+ cations and aqueous nitrate ions will migrate between the two half cells. Negatively charged aqueous nitrate ions or anions will flow towards the anode to cancel the positive charge created by the excess aqueous copper 2+ cations, which were produced by the oxidation of copper. The name anode refers to the fact that this electrode will attract aqueous anions. The positively charged aqueous potassium cations will now flow towards the cathode to cancel the negative charge from the excess nitrate ion, which was left behind when silver ion was reduced to silver metal. The name cathode refers to the fact that that electrode will attract aqueous cations. These processes will allow the Voltaic cell to maintain an overall charge of 0. The voltmeter will measure the amount of electricity produced during the process. In summary, try to remember the following. Voltaic cells use a spontaneous oxidation reduction reaction to generate electrical energy. Voltaic cells convert chemical energy to electrical energy. The anode is the site of oxidation. It decreases in size and is negatively charged. The cathode is the site of reduction. It increases in size and is positively charged. The salt bridge allows ions to migrate between the two half cells, and electrons will flow away from the anode and towards the cathode. This concludes my lesson on electrochemical cells, the Voltaic cell. I'm Mr. B.